Fast, as they say. Thank you. All right, so my name is Tanya Bragin. I'm VP of Product at a company called ClickHouse. Just a quick show of hands, who here has heard about ClickHouse? A couple of hands, that's great. Who here has heard of a company called Elastic, company behind Elasticsearch? A lot more hands go up. Okay, so previously I was at Elasticsearch. I'll do a little bit of an intro in just a minute. I am a product manager by training. Before then I was a consultant, so I started off as a practitioner. And I would say I really enjoy working with open source technologies at open source companies. I've now spent the last 10 years at 2 such companies. And specifically, my role has been adopting these databases to observability use cases. So I'll talk about that, but primarily here, I'm here to talk about a trend that is real, that is not only related to ClickHouse, but is related to the whole industry that we're calling SQL-based observability. So hopefully you do find it useful. And it's not for everyone, so I will try to outline whether or not it's the right choice for you and your organization, because there are different requirements, different teams with different needs. So I'm going to start with a bit of a historical context and then go into some real-world examples, because I can talk here all day about SQL-based observability, but you probably want to know what your colleagues are doing and how they're doing it. And then I'm going to zero in on specific considerations, things that you will have to think about as you go on this journey, if you end up going on this journey. And a little bit of a look into the future. We'll see if my predictions actually bear out. So historical context. First of all, SQL. Hopefully everybody here has heard of SQL. It is 50 years old. 50 is the new 30, though. It's okay. It's still very, very popular. If you look at the Stack Overflow Developer Survey, it's number 3. Number 3 programming language. Believe it or not, SQL is actually Turing complete. I don't know if you knew that. I didn't know that. Does anybody know actually what the first SQL database was? Relational software, which became Oracle. Correct. I had to look it up too. I didn't know that. Anyway, it's really, really popular still. In fact, many of you probably still run Oracle, but that's not why it's popular. The reason it's popular, actually, is because it's making a comeback. So since the days of Oracle 50 years ago, there have been a number of sort of iterations to what SQL has done. It was applied to this area called OLAP, Online Analytical Processing. But those systems were quite niche. I didn't even know, like Hyperion, Essbase. I've never used it. There's a few others that I have worked with as a consultant, but they were quite, I would say, for the few and the chosen within the BI team, and not something most of us as practitioners really had access to. Very expensive systems for a lot of data. Until the cloud data warehouses. Who here has heard of Snowflake? Yep, Snowflake, that's right. So you've heard about it, even though it's not in a DevOps suite. Why? Because it's a very easy to use cloud data warehouse. It really democratized this concept of an OLAP system because it made the experience of both running and using a data warehouse much, much, much easier. There's others like Redshift, BigQuery. This has really brought SQL back to the forefront of many, many engineers and analysts. And now, where we are right now, within this domain, it seems like every week there's a new open source real-time analytical database. So ClickHouse is one of them. ClickHouse got open source in 2016. There's others that preceded it, like Pinot and Druid. But this area is really heating up. And what's really interesting about it, and this is what I'll talk about on the next slide, is it's starting to make inroads into observability. But before I go there, let's look at what is observability. Just like SQL, it's actually also 50 years old, believe it or not. Happy birthday, observability. It started in systems engineering. If you read computer science textbooks, it talks about, if you have a system, in order to be observable, which is the quality of the system, it has to have outputs that you as an engineer can look at to know what it's doing. There's a lot of theory behind what it is. In practice, it became much, much more relevant to all of us in the days of Unix, when we realized that we had Linux and Unix systems. We had to somehow observe multiple systems, and so syslog and rsyslog in particular has really become the first way that we kind of centralize this information. But Linux or Unix is not the only systems that we had, so Splunk was kind of the first, I would say, technology agnostic centralized software, right, and vendor that tackled this problem. Of course, Splunk was an innovator, right, and still many of you probably run Splunk. It makes sense. Where I kind of joined the story is I joined Elastic on the ground floor. So I was one of the first PMs. And when I joined, they're like, yeah, why don't you look at the logging use case? And that became the primary use case for Elastic for a long time. The Elk Stack, of course, was the open source alternative to Splunk. And then just like in the data warehousing space, Datadog sort of made that whole experience of running centralized observability very much easy with a hosted offering. So the same kind of progression happened in observability. And just like in the data warehousing space, we see a lot of open source activity now, including open source standardization. So open telemetry, we're actually ahead of the data warehousing space. We have standards both for shipping data and semantic conventions. The BI community still very much struggles with that. So the fact that we have this culture of building a type of open source is really helping us not only develop our own technology, but also look in other areas and pull over technologies that make sense for us. But why would we be doing that, right? Because again, there's a lot of activity. There's also Grafana with the Loki stack. So why even look? And the reason you would do that, the reason you would take a SQL-based, all-up database and apply it to observability, ultimately is a disruptive level of innovation and benefits that it would bring you, primarily because of cost and performance. That would be the reason, right? We deal with a lot of data. Ultimately, observability is a big data problem. We all struggle, I would say, to serve our customers because ultimately, if they had their ways, they would store all the data forever. Of course, that's not realistic, right? So when there's a technology that allows us to either, significantly reduce costs, or for the same cost of a platform to store 10x more data or provide 10x more lookback, that's attractive to our customers and it's something that we have to look at. But as I mentioned, 10x is important. Usually you wouldn't make a migration for 1.5x or even 2x benefit. It has to be disruptive. But that's exactly what's happening right now. So we'll talk about this in a minute. Before I jump into examples from the real world, a typical architecture today for do-it-yourself stacks and observability looks something like this. You have data shippers. Maybe you've standardized on OpenTelemetry, maybe not. Maybe you have some custom or vendor-specific ways of shipping data from your applications. This could be logs, metrics, traces, profile data. There's a number of signals. You could optionally be using something like Kafka or another message bus to mediate that. It's a great way to also transform the data to the same format, if it's in different formats. And then you have data stores, and which can vary by signal. On the UI front, Grafana is really a great resource to use across many different data stores. Kibana, of course, is Elastic specific. You could have a custom UI as well in some organizations. SQL-based observability looks very similar. Notice there's not a ton of difference on the slide. The data store is simply just a SQL data store as opposed to a kind of a NoSQL or a custom data store. So that's the good news. The architecture does not need to change. You may need to sort of architect the insides of this black box in a slightly different way, but the overall architecture is the same and will look very similar to you. I'll talk about the UI pieces when I get into common considerations. So that's the good news. But let's first talk about the real world examples. Is there anybody doing this right now? And of course, right? I mean, I wouldn't be up here talking about if this was a dream, right? So in 2018, Uber famously, hopefully some of you have seen, published a blog where they talked about moving to a SQL data store from Elastic for their logging deployment. And at that time, it was just sort of revolutionary. Why would you take ClickHouse? It was built for clickstream data, right? Web analytics, data warehouse, like on the web analytics side. Why would you put that in your logging stack? And the reason was drastic cost savings. In their case, they actually applied it to processing and storing more data, right? They didn't significantly choose to reduce their hardware footprint. They chose to keep more data for their users and their engineers to troubleshoot problems more effectively. They kept the log shippers. They kept Kafka. They, for their analysts, because they were already used to Kibana, they modified Kibana to talk to ClickHouse. That was the best solution for them. So the wins was speed of ingestion and cost control. The trade-offs was, a new stack to administer and this additional UI development. You can find all of this on Uber's blog as well as a meetup talk that they did where they deep dived on this use case. So this was 2018. Since then, many companies followed. So Comcast, Disney, to media companies with huge amounts of traffic to serve their media pipelines. Famously also talked about their use cases. But by the way, this is the diagram from Uber. It is quite simple. The only thing here that I guess I will mention is an index optimizer. So one thing that's important to understand is that SQL data stores are typically not schema agnostic, right? They have a schema and you have to think about that. So I'll talk about that in considerations. So they have a process to modify an index per schema that they define for their users. But anyway, a more recent example, going to real world examples. 2 weeks ago at KubeCon Europe, eBay talked about their tracing use case. And here, again, they replaced a data store, which they didn't name. I know what that is. And they put ClickHouse in, getting data from OpenTelemetry. So in their case, they're completely standardized on Apache 2. They're completely standardized on OpenTelemetry, but they have a custom UI. And their architecture looks like this, where they have applications, OpenTelemetry collectors. As it turns out, from their KubeCon talk, that was the hardest part. The hardest part was actually tiering OpenTelemetry to do sampling in an effective way at their huge scale. And all of that ultimately goes into a trace store, which is ClickHouse-based, metric store, and ShareLook is the name of their custom console they built for their engineers. So this is a more recent example. And as I mentioned, there are many companies in between. At ClickHouse, we, of course, also drink our own champagne, and we have a cloud offering. So while we're an open source technology, we as a company, our commercial go-to-market is cloud. We have cloud engineers. They would like to look at their logs. We have database engineers that literally want to store every server log forever. This is just how they roll. It would be a huge cost. We actually tried to sort of see how much it would cost us in Datadog. It would have been ridiculous, right? It just is not a solution for us given our needs. And so for granular log retention, we took a look at what it would take to build this ourselves using ClickHouse. 1.5 FTEs, so 1 to 2 engineers, depending on a quarter and a project, 6 months to build the stack, and we're maintaining it now. We've published a blog on this. The architecture, as I mentioned, is quite simple. It looks exactly like it would look like with a non-SQL store, but the data volumes are staggering and the compression ratios are staggering. So this is what I'm talking about. By adopting a technology from another space, if the technical underpinnings allow you to do something in a 10x more efficient way, it may make sense. So we'll see the considerations in a minute. This is the cost of our stack based on ClickHouse. If you overlay with it Datadog, that line looks basically flat, right? For us, really, it makes sense to run with this DYI stack as opposed to using a cloud offering. Even if you compare it to something like Elastic, right? So the yellow line is a ClickHouse-based solution. Pink here is Datadog. Elastic is blue. Even though it is open source, because of a few considerations I'll just mention, one of which is automatic indexing or not, Elastic ends up being quite pricey as well. And that's because of the underlying choices that data stores make around indexing your data in a schemaless world. All right, so let's talk about these considerations. I already mentioned schema several times. And this is, again, specific to SQL OLAP data stores. They assume a schema. It's ultimately a database. It's SQL for a reason. It defines a schema. So for instance, in the case of eBay, they had to think through their trace store. Like, what is that going to look like from a schema perspective? There's a big table with traces. Trace ID is indexed on, this is what you use to index the other tables. For instance, you would then look up the tenant in another table. So you would do a join. So this is their architecture. Uber actually took this database that requires a schema and built on top of that a schema-agnostic data model, as they called it. They used more complex data structures like maps and objects to define for their users a set of key value pairs, but they have to do the work at ingest, right? So there is work required to think through your schema, and if you're going to approach it in a schema-agnostic way, to think through your ETL pipelines. So that's one of the trade-offs that you will have to make. One other thing I did want to mention, I think there was a speaker earlier in the morning session that talked about this, and I completely agree. This difference between logs, metrics, traces, if you are going to approach it with a all-up data store, it's useful to actually not necessarily think about all these events separately, but think about just events and attributes. Some are numeric, some are strings. It really helps in some cases to not necessarily be very strict about distinguishing between the sources of data. Just think about your customers, think about what they need, and store them as what's called wide events. So this is an example from a recent Hacker News thread based on a blog that one of the practitioners wrote. Really good discussion if you haven't seen it. By the way, I don't know if folks read Hacker News here. I'm on it quite a bit. I thought this was a fascinating discussion. I would highly recommend digging into and thinking through that part of the schema. All right, so you figured out the schema. You have your shippers shipping data. What about the UI? In the end, analysts, to be productive, they need to look at this data, right? Just storing it, no matter how efficiently, that's not enough. All right, so let's talk about it. Grafana, for a while, I would say, has been the only game in town, but it's a really good game. It's very easily extensible. ClickHouse, in particular, has a plugin for it that looks really good for logs, traces. Looks as a native data store would look like in Grafana. Interestingly, though, and I was talking to a few folks here, not everybody was aware, there's a project out there, may or may not have heard of it, called Perses. It's an Apache 2 licensed alternative to Grafana. Grafana is AGPL. Very, very early project, but I'm personally watching it very carefully. The project states that the goal is to mature it and donate this UI to CNCF. If that happens, that could be really, really interesting. Obviously, we would love for Perses to have the same kind of plugin model to different data stores as Grafana does. I think they've done that very well. So we'll see, right, how this evolves. There's a lot of innovation happening in the UI space as well. As Uber did, though, if you have existing users and they are used to Kibana or Splunk, well, you know what? You may have to, for some time, use a side-by-side strategy where you're sort of like offloading some data sources and keeping the UI. For Kibana, Uber had to build their connector. Now there are actually some standardized connectors. I'm listing one of them. And for Splunk, there's something called DB Connect. And it's there to query SQL data stores. And guess what? All app data stores are SQL standards, so you can use that. So actually it works quite well. You can use Splunk with something like ClickHouse, and Splunk remains the front end. And your engineers on day one don't have to change how they query. You could build your own UI. There, I would say, if you're really going to start from scratch, maybe also look to something like Apache Superset. It was built for business analytics, but because it's SQL compatible, it could be a great starting point. It's Apache 2 licensed. You can modify it, and some organizations use it not only for business analytics, but for DevOps as well. So tons of options actually there on the UI side. Query language. This is another question I sometimes get. SQL. Is it really going to be as compact as domain-specific query languages? Depends, right? I mean, if you look at this example, on the right we have Splunk. On the left we have Elastic Query DSL. Of course, you wouldn't actually write that. That's what Kibana would spit out and send to Elasticsearch. It looks okay. I mean, on the Splunk side, this is querying duration and grouping it by level. The SQL doesn't look so bad. I mean, look, I'm not a SQL pro. I would say, like, before I joined ClickHouse, I didn't write a lot of SQL, but this is perfectly humanly readable. Is it always going to be as simple in every example? Maybe not. And this is where, and I'm actually really proud of myself. I got to this point in the talk without mentioning GenAI, but now I will. GenAI to the rescue, right? SQL, it's 50 years old. It's very standardized. It's super easy to write a copilot that takes natural language and converts it to SQL. Actually, much simpler than for domain-specific, kind of more unique query languages. So actually not very hard. This is an example from our cloud offering. In our Grafana plugin, we'll have something like this very soon. You don't know SQL, it's much, much easier to learn that today compared to even a couple of years ago. A few other considerations, and these are not specific to SQL data stores. In any do-it-yourself stack, you will have to think about multi-tenancy. This is something that Uber, of course, thought through, and they talked about in their blog and presentation. There's nothing super complicated here. You'll have to figure out if you can limit your users by resources in a multi-tenant system. The good news is that OLAP data stores, because they were developed for BI domain, this is very real there as well, usually have really good controls for that. And multi-region considerations. Again, this is something, if you've been building your own platforms, you already know. Data gravity in observability is real. Likely you're going to be leaving your data in regions, but then the question is, how do you query it across? So for instance, do these data stores support distributed querying, federated queries, because that's going to be potentially an important part of how you architect. In the case of Loghouse, which is our logging system at ClickHouse, we actually rely on Grafana's ability to federate queries, which are quite great. And we discussed that in the blog that we publish, how we've been able to approach it. So in the end, right, if you're looking at databases outside of the observability domain, if you're looking specifically at SQL OLAP data stores, some considerations, at least based on the customers that I've spoken with. First of all, not all SQL OLAP data stores are made equal. Some are built for more real-time use cases, and some are built for more offline analytics. When I say real-time, I'm putting it in quotes because it could mean a lot of things to a lot of different people. In the end, in observability for us, what matters is streaming data ingest, so always on, and fast queries fast meaning like a couple of seconds, that a human basically would not get bored by and it will not walk away from a console on large amounts of data. So that's what I mean by real time, something that's really built for offline reporting, very large, running 10-hour report with a huge join. That's not really what we're looking for. Data compression, that's the biggest impact on cost savings. If your data compression is 2x, that's not enough. You really need to look at something that's going to deliver 10 to even 100x compression in data in order to get the kind of cost savings I'm talking about. And another thing that's going to be important is separation of storage and compute. Putting especially cold data onto object stores and still being able to query it, scaling compute separately, that becomes important at scale. So ability to do that in a data store is going to be table stakes. Interoperability. How easy is it for you to take this data store and just put it in your existing architecture? Do the other pieces just continue to work? That's, again, also part of your migration costs. SQL compliance. The reason I put it here is, of course, GenAI and copilots. The truth is, no data store is 100% ANSI SQL standard compliant. They're all a little bit different. There's a Postgres variant of SQL. There's MySQL. So everything is a little bit different. How close do you get is really the question. And again, that influences how easy it is, how transferable is the skill set of an analyst that comes to the system. And I've already talked about TCO. In my opinion, switching costs really start making sense at like maybe 5x. Even if you improve something by 2x, usually switching costs, maybe then it's a wash. So just to kind of to pull up a comparison, ClickHouse, interestingly, again, has been adopted the most, I would say, in this domain, but it's not the only SQL OLAP data store. There's also Apache Druid, Apache Pinot, which preceded ClickHouse. As I mentioned, there are others that I see on Hacker News all the time. I don't know all of them, but I know there's a lot of innovation happening here. One that sort of doesn't fit here because it's not an open source system is actually BigQuery. Right? So this is a data warehouse that is often used for storing logs that are a little bit less frequently queried. And the reason it makes sense there is their pricing model is by scanned amount of data. And so if you're just going to put your logs somewhere and mostly don't query them, sometimes BigQuery makes sense. It's not also great for building real-time applications, but it's good for, again, sort of like storing a lot of logs and occasionally querying them. So applying, again, data warehousing and SQL-based technologies to the space is happening. It does make sense, and the considerations you just heard about. My prediction, and I'm not Gartner, I realize, but let me just tell you my prediction. We'll see. If you invite me next year, maybe we'll see if it plays out. Is I do think observability costs will continue to gain scrutiny from our leadership in this industry, not just due to the economic times. It's just, as every industry matures, we get more and more savvy and we start asking questions. about, including around efficiency. As a result, DevOps engineers will continue to search for disruptive solutions to various challenges, including cost and performance. And I do think that real-time OLAP databases the ones that provide the benefits, 5 to 10x benefits, will continue to help us on this journey. So thank you very much. If you would like to see more, there are blogs you can read, both from ClickHouse and from users I just mentioned. You can also find me on X, LinkedIn, and Medium. And thank you so much for staying. I really appreciate it. Please let me know if you have any questions.
Do we have any?